build the heart. We will make an acorn-shaped heart in red clay, a long red clay tube for the aorta, and a T-shaped blue tube for the pulmonary artery. Here is the heart. It is about 3/4 of an inch long and about 3/8 of an inch in diameter towards the apex, and about 3/4 of an inch in diameter towards the base of the heart where the valves attach. Cut a piece of red clay and warm it in your hands. Then roll it out into a heart shape. Roll your hand in a circular direction to create a sphere. And then roll the clay with your hand angled down to create that acorn shape or thick fat carrot shape. Now use your wooden knife to score around the top of the heart. This will be the dividing line between the atria and the ventricles. The atria will be at the top and the ventricles at the bottom. Now take your wire loop and cut a notch between the left and right atria. Use the wire loop to create an indentation for the root of the aorta and the pulmonary trunk. This is where we will be putting the great vessels of the aorta and the pulmonary artery. The aorta carries blood from the heart to the rest of the body, and the pulmonary artery carries blood from the heart to the lungs. This is called pulmonary circulation. Now we are scoring a line between the left and right atria. Here is our aorta for the model. It is about a 3-inch tube. In humans, they are about the size of a garden hose and have a thick wall to withstand the pressure at which the heart is pumping blood. The aorta is the major systemic artery and arises from the left ventricle of the heart. So take another small piece of red clay and roll out the aorta. Warm it up with your hands before rolling it. Then take your wire loop and cut the aorta down. And stick the red clay tube into the indentation you created. The aorta will arch over the back of the thoracic cavity, so once you attach the tube, you can curve it back around the heart. Here is our pulmonary trunk, which is the vertical line of the T, and then it divides off into the cross of the T, which are the right and left pulmonary arteries. The pulmonary arteries carry blood to the lungs. So cut a small piece of blue clay with your yellow scraper. Roll your blue clay into a small tube. Blue is traditionally used to show venous blood or spent blood. Spent blood is blood coming back from the body to the heart and then being pumped out of the heart towards the lungs. Normally veins are blue because they use venous blood. But in this case, it will be an artery because the artery carries blood to the lungs to aerate it and recharge it with oxygen. Use the wire loop to cut the blue clay tube. Then attach the tube to the indentation of the heart next to the aorta. And bend the blue clay back slightly. Use your wire loop to cut the pulmonary artery and use the cutting to create the crossbar of the T-shape. This crossbar will make the left and right pulmonary artery which go to the right and left lungs. Now take your red clay tube, the aorta, and bend it so it goes over the top of the T and then travels back down behind the heart. Now we will add another 4-inch length tube to the aorta. This will be the rest of the aorta. The aorta extends through the thoracic cavity into the abdominal cavity. It is the largest artery of the body. Many of the aorta's branches are named after regions of the body. So roll out more red clay into a tube and smear it onto the other piece of the aorta. Now we can install the heart in the thoracic cavity of the mannequin model. The heart sits right on top of the surface of the diaphragm, with the apex, the pointed part of the heart, angled towards the left. Now the aorta goes down through the diaphragm and down along the left side of the spinal column into the abdomen. To review, the heart sits on the diaphragm in the chest cavity and the apex tilts left. The aorta divides into two parts. The upper part is the thoracic aorta, and the lower part is the abdominal aorta. At about the 5th lumbar vertebra, the aorta will divide into the right and left common iliac arteries. So we will create a 7-inch long red clay tube. Roll out some more red clay and use your hands to spread the clay to increase its length. You can use shorter strokes when working with thinner pieces of clay. Take the wire loop and cut it to about 7 inches. The arteries, as they branch into the body, get smaller and smaller like branches on a tree. So this artery should be slightly thinner than the aorta. We are plugging in our common iliac artery, running it through the pelvis where it becomes the external iliac artery, and then as it runs over the brim of the pelvis, it becomes the femoral artery. The red clay tube should lie along the femur. An important part of the cardiovascular system is the kidneys, so we will build one now. The kidneys are also a very important part of the urinary system. Here you see the completed shapes. We will need yellow, white, and red clay to build these items. Here is the kidney itself, which is shaped like a kidney bean. The indentation of the kidney is called the hilum. The hilum is where the vessels and the renal pelvis enter into the kidney. The kidney determines what remains in the blood and what is removed. It is the body's filter. It has a huge blood supply for its size. In human beings, the kidney is only 150 grams, but it gets about a quarter of the cardiac output. Roll out a small red clay piece into a ball that is a little less than an inch. Flatten it slightly and use your fingers to make an indentation for the hilum. You can move your fingers around and dab them on the clay to shape the kidney. Once you are happy with your kidney bean shape, we can create the renal pelvis. The renal pelvis is a very tough white connective tissue in the shape of a funnel. The renal pelvis funnels the urine from the kidney into the ureter. So here we take a very small white piece of clay and roll it into a tiny carrot. Angle your hand down as you roll the clay to force the tube into a carrot shape. Use your wire loop to trim the pelvis and then flatten it slightly. Then stick the wide end of the renal pelvis into the hilum. Now take the remaining clay and roll a long, thin tube for the ureter. The ureter for the model will be about 6 5/8 inches in length. The ureter carries the collected urine from the kidney to the urinary bladder. Roll out the ureter and move your hands apart as you roll to increase the tube's length. The ureter is a tube of smooth muscle that forces the urine along, just like the peristalsis in the gut. Once you have your tube at about 6 5/8 inches long, plug it into the point of the renal pelvis. Next, we will build the adipose capsule in yellow clay. This capsule is a fatty mass surrounding the kidney and holding it in place. It is just a flattened oval. So roll a fat yellow clay tube, flatten it with your hand until you create an oval shape about 2 1/4 inches by 1 inch. We will wrap this flattened oval around the kidney as a packaging to protect it against trauma. The adipose capsule helps protect the kidney, which is only partially protected by the ribs. Now we will roll out about a 2-inch red clay tube for the renal artery. This is a thick artery and needs to be thick for the amount of blood the kidney receives. The renal artery is a branch of the aorta that carries blood to the kidney. Use your wire loop to cut down your red clay tube and attach it to the kidney at the hilum. Now we will attach the kidney to the model. Take the kidney and press it as far back and up as you can into the model, just below the rib cage. Then attach the renal artery to the aorta. You can pinch or cut off the excess. The renal artery is one of the branches off of the aorta. We are just putting in the right kidney, but if you have a left-sided model, you could put in the left kidney. Run the white clay tube or ureter down the back of the abdominal and pelvic cavity to the posterior surface of the bladder. The kidney lies approximately at the level of the 12th rib. Now we will create the blood supply to the arm. We will make 3 thin red clay tubes, one 12 1/2 inches for the subclavian artery, the second 4 1/8 inches for the ulnar artery, and 3 1/2 inches for the carotid. Several arteries change their names as they branch off the aorta and go down to the elbow. First, we will create the subclavian artery, which is about 12 1/2 inches. The subclavian artery is a branch of the brachiocephalic trunk. The brachiocephalic trunk is a branch off of the aorta. The subclavian artery and the common carotid artery branch off almost immediately from the aorta. The subclavian artery goes to the arm and the common carotid artery to the neck. The second tube we roll out is for the ulnar artery. So roll another tube. We will attach the subclavian artery. This artery will change names along its path. The brachiocephalic trunk will be under the rib cage. Take the red string of clay and place it under the clavicle. Along this path, just below the clavicle, it is the subclavian artery. As it travels down the axillary, it becomes the axillary artery. And as it moves down the upper arm, it becomes the brachial artery. So this is just one artery that has a lot of name changes as it travels down the arm. Past the elbow, it crosses over and runs along the radius, and it is called the radial artery. Now attach your second string of clay and run it along the ulna to create the ulnar artery. We will add a little more tubing to the radial artery so it extends to the hand. The radial artery is where you feel your pulse on the lateral side of the wrist. To review here, we have the subclavian artery running under the clavicle, the axillary artery in the axilla or armpit, the brachial artery running down the medial side of the humerus, the radial artery along the forearm, and the medial ulnar artery. Now our third tube will become the common carotid artery. Roll out this tube in red clay again. This will branch again off the brachiocephalic trunk. This will run up the side of the neck just behind the jaw. And this is where you can feel the carotid pulse. Also, if you press on this artery, you can cause a person to faint. This completes our lesson on the cardiovascular system.